Hello everyone. In this video we're going to be solving an interesting cubic equation. I call it interesting because we have complex numbers on the right hand side and we have the cubic on the left hand side. So we have 2x minus x cubed equals 3i, and we're going to be solving for the x values. So I'll be presenting two methods, and let's start with the first one. So for my first method, I'm going to be using a brute force approach. Even though I'm not going to complete it, I'll show you the method. Hopefully you can take it from there. So let's go ahead and put everything on the right hand side. So that's going to look like x cubed minus 2x plus 3i equals 0. Now if you had like a 3 instead of the 3i, maybe you could go ahead and solve this problem, right? Maybe like this, or maybe with a little manipulation, like what if we had x cubed plus 2x and then minus 3. Then you could definitely guess and check for this one because there's an obvious solution, and then you could go from there. But we have the 3i, so the scenario is a little different, and we'll talk about that in more detail during the second method. So for the first method, we're going to use the cubic formula. And so for that purpose, let me go ahead and write down the cubic identity, a plus b cubed. From that, subtract 3ab times a plus b, and you end up with a cubed plus b cubed. So here's what we're going to do. We're going to go ahead and call this x. And then from here, we're going to compare these two equations. Notice that the coefficient of x, which is a plus b by the way, is negative 3ab, and the coefficient of x here is negative 2. So we're going to set negative 3ab equal to negative 2, which implies ab equals 2/3. Alright, so let's go ahead and save that, and then look at the other value. Since I don't have the constant here on the right hand side, let's go ahead and subtract 3i from both sides here, and write this as this equals negative 3i. Now I have a constant here and I have a constant here, so I can go ahead and compare them, and that gives me a cubed plus b cubed equals negative 3i. So together these two give me a good system, and that's actually, even though it kind of looks cubic, this is going to be a quadratic system because a and b are multiplied. So let's go ahead and cube both sides here, a cubed b cubed equals 8 over 27. We're actually using this one. And then from this second equation, let's go ahead and isolate b cubed and write it as negative a cubed minus 3i. So that's something that we want to substitute here. Okay, makes sense? So that we can get a cubed times b cubed, which can be written as negative a cubed minus 3i equals 8 over 27. And then if you distribute, you're going to get negative a to the 6 plus, actually that's a minus sign, minus 3i a cubed equals 8 over 27. And if you put everything on the right hand side so that a to the 6 becomes positive, then we're going to get the following result. Everything will be positive. And we'll get a quadratic because if you set a cubed equal to c, then you're going to get c squared plus 3ic plus 8 over 27 equals 0. Hopefully you can see what I see. And then this equation is very easy to solve with the quadratic formula. And the quadratic formula says c equals negative 3i plus minus the square root of negative 9 minus 32 over 27 from the minus 4ac divided by 2. Great. Well, not so great, but it's sort of great. From here, you're going to get negative 9 times 27, which is negative 243. Subtract 32 from it, you're going to get negative 275. So this is going to look like negative 3i plus minus, and you're going to square root 275, which can actually be written as 11 times 25. So outside the square root, we're going to have a 5, and then inside 11. And then because of the square root of 27, we're going to have a 3 root 3 at the bottom. And then divide the whole thing by 2. If you rationalize the denominator here, like multiply by root 3 over root 3, then you're going to get something like this. C equals -3 plus minus 5 root 33 over 9. And then all of that is divided by 2, and so on and so forth. Let me tell you what's going to happen. You're going to find the values of C, set this equal to a cubed, and then from here a, you're going to find a by cube rooting C, but there are two values. One of them is going to give you a, the other one is going to give you the b value. So if I call these C1 comma 2, and if this is C1, b is going to be the cube root of C2. And it doesn't matter which one is which, but at the end, x can be written as a plus b. So we're going to have a very, very radical expression. We're going to have to deal with the cube root of a complex number. So that is going to be a little complicated or time consuming. Let's go ahead and take a look at the second method, which is much cooler. All right. So here's the second method. For my second method, I'm going to do the following. Let me start with the original problem. Always keep that in sight. And now I want to put everything on the right hand side as before. X cubed minus 2x plus 3i equals 0. Like I said earlier, if we had x cubed plus 2x minus 3, notice that x equals 1 is a solution because 1 plus 2 minus 3 is equal to 0. So we can kind of manipulate this equation to reflect that x minus 1 is a factor because x equals 1 is a solution. Okay? So factor theorem tells us that, and we can basically x cubed minus 1 plus 2x minus 2, and then we can kind of group and factor. This is splitting up the constant so that we can make it factorable by grouping. And guess what? We can do the same thing here. How? Let me copy my equation here, and here's what we're going to do. We're going to split the 3i because that's our constant, isn't it? And naturally, looking at the coefficients, 1 and -2, it only makes sense if you split it up into 2i plus 1i. Make sense? Okay. You could also do 4i minus I, and try it, but you're going to notice it doesn't work. But this one does. And how, you may be asking? I'm going to put these two together, because these two go well together. Make sense? So here's what we're going to do. We're going to write this as x cubed plus I minus 2x plus 2i equals 0. Now at this point you might be wondering, what am I going to do with x cubed plus I? We'll tell you, or I'll tell you in a little bit, but let's go ahead and take out a -2 here. This should give you a good clue. So I do need x minus I. If my expression is factorable by grouping, I should definitely have x minus y here. So is this divisible by x minus I? That is a $1 million question. And the answer is yes, because I cubed is -I, therefore I is -I cubed. Make sense? So let's go ahead and replace. Okay, is this right? Yeah. So let's go ahead and replace I with -I cubed. And then everything hopefully will be clear, crystal clear. Now this is difference of two cubes, x minus I, x squared plus ix plus I squared, minus 2 times x minus I equals 0. Then x minus I take out, you'll have x squared plus ix plus I squared, which is -1, minus 2, -3. Minus 1 minus 2 is -3, and that's a bad 3. So let's make it nicer, and this equals 0. And from here, finding the solutions fairly easy. This gives us x equals I, which is one of the solutions, and the other solution is going to be the quadratic, which is x equals -I plus minus the square root of I squared plus 12 divided by 2, but that can also be written as -I plus minus square root of 11 over 2. You could also write this as plus minus root 11 minus I divided by 2, which is more standard. All right, and this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.